Okay, in this video we are going to talk about probability, and that's going to fall really in this part, testing hypothesis. And so why don't we start with a rain forecast. And so today there was a forecast for rain, and at 5 a.m. there's a 40% chance of rain. Now, you can see at the top I wrote that forecasts are not predictions. And what I mean by that is that if it rains today, the weather person was right, and if it doesn't rain today, the weather person was also right. They're not wrong. They're just saying there's a 40% chance of rain. They are not saying that it will rain or that it won't rain. But let's start with how you calculate probability, and we got a simple example here. And so if you flip a penny, you have two choices, right? It can either land heads or it could land tails. And it's about a half chance, 50% chance that it lands either one. And so how do you calculate probability? You look at the number of outcomes that you're looking for versus the number of all possible outcomes. So if we wanted to know what is the chance of heads, the number of chances of heads is 1 out of how many possible outcomes? 2 out of 2 outcomes. So 1 over 2 is 50%. Let's take another look, and this time we will look at dice. And so you can see when you roll a dice or a die, there are 6 potential outcomes that can come here. So 1 out of 6 is the probability for any one of these particular numbers. And that comes out to about 17%. So if we want to know what's the probability of rolling a 3, there's 1 possible way of getting a 3 out of 6 possible outcomes that we could have. And so 1/6. Let's take another look here. What if we want to get a number less than 3? So that means either a 1 or a 2. So there are 2 ways we can get a number less than 3. We can either roll a 1 or a 2 out of 6 possible outcomes. And so 2 divided by 6 equals 33%. So the probability there is 33%. What is the probability of rolling a 7? There's 0 ways of getting a 7 when you roll a 6-sided die, right? 0 out of 6 possible outcomes. So you have 0%. There's no chance of getting a 7. And what's the probability of getting a number between 1 and 6? Well, there's 6 ways of getting 6 potential things we could do. We could get any of the possible 6 numbers here, and there's 6 potential outcomes. So 6 over 6 is 100. So there's a 100% chance. We're guaranteed that we will get a number between 1 and 6. And so now we want to apply this to diagnoses, right? And so we are going to have a diagnosis under consideration, and it's going to have a number, a probability that we're going to apply a percentage to. Now, it's not really that mathematical. We can't really say that something is 41% likely because we don't have enough information to make that calculation like we did with flipping a coin or rolling a die. And so why don't we just come up instead with some generic terms here? So anything that's less than 10% we'll call very unlikely. Unlikely is 10 to 30%. 30 to 70% is uncertain. 70 to 90% is likely. And greater than 90% we would call very likely. These categories I pulled from a video by Dr. Catherine Lucy. And how do you determine where a diagnosis would fall in here? Now we'll go back to that video that we had from illness scripts, right? If something has rejecting features, we could say, it's pretty unlikely. And if it has those key features, especially many key features, we would say that it's very likely. And anything in between there, maybe it has a few differentiating features, we call it likely, or it has very few differentiating features, we would call it unlikely, and anything else in the middle we would call uncertain. So we are making an estimate. We're not actually calculating a probability of a diagnosis after we look at a patient. We're making an estimate, and that's part of the skill of clinical reasoning. Now, one more thing that we should talk about is that there's no such thing as certainty in medicine, right? Like when we ask what was the probability of getting a 7 when rolling a die, it was a 0% chance. Or getting a number between 1 and 6, it was guaranteed. But in medicine, you can never be guaranteed anything. You can never be 100% sure of a diagnosis, and you can never be 0% sure, or that is certain that they don't have a diagnosis, because there are too many factors at play. And so we could be very, 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 very certain they don't have something, and so maybe it's approaching 0, but we'll never be 0 because you just never know. There's too many factors that we can't make account of what does it mean for something to have a probability of diagnosis? So let's say that we say that the probability of migraines is 87%. That means there's an 87% chance that you're right and a 13% chance that you're wrong, right? So if they actually had a migraine, right, then we say, oh yeah, we had it right. There was an 87% chance of that. But if they did not have a migraine, and we said that they did, we said we were 87% sure, then there's a 13% chance that we would be wrong. And we have to ask ourselves, can we live with that 13% chance of being wrong? Or do we need to somehow make that smaller? Let's look at meningitis. Meningitis is a deadly disease. It's an infection of the brain that can kill you. And let's say that we thought there was an 11% chance that this person had that. Okay, so that means, and we are saying that they don't have that diagnosis. They do not have meningitis. So there is an 89% chance that we are right, that they don't have meningitis. But there's an 11% chance that we would be wrong if we say they don't have meningitis and they actually do. And so we have to ask ourselves, can we live with an 11% chance of being wrong? Is that something that we feel comfortable with? How you answer that question, we'll talk about a little bit later in a different video. So that's really what I wanted to talk about here is the main concepts of how do you calculate probability. And when you get a probability of a diagnosis, it's not saying that the patient has that diagnosis. It's a forecast. It's not a prediction. And it comes with this calculation here of, okay, there's this % chance that I'm right and this % chance that I'm wrong. Am I okay with that? And we're going to look at those in greater detail in the next videos. Thank you for watching.